Okay, here's section 2, homework. This is actually a lot easier than the first section. So what we did in section 1 was we used matrices as kind of a vehicle to solve linear equations. There are other reasons for using matrices, and there are operations like addition and subtraction and multiplication that we do to matrices. So that's what this section's about. So the first 2 problems are just adding the 2 matrices, subtracting the second matrix from the first matrix, multiplying the matrix by a constant, and then multiplying the matrix by a constant and subtracting the second matrix by a constant. So that's what we need to do. So problem number 1, when you add the 2 matrices together, you add the terms that are in the same location. First row, first column. This is for row 1, column 1. This is row 1, column, row 2, column 1, column 2. So this is row 1, column 1. This is row 1, column 1. So we just add these together. 1 plus 2 is 3. Negative 1 plus negative 1 is negative 2. 2 plus a negative 1 is 1. Negative 1 plus 8 is 7. Or 8 minus 1. Okay, so that's first thing. Then we have A minus B. So we subtract these from those numbers. So you have 1 minus 2, which is negative 1. Negative 1 minus negative 1, which is the same as negative 1, plus 1, which is 0. 2 minus a negative 1, same as 2 plus 1, which is 3. And negative 1 minus 8, which is negative 9. Okay, so that's A minus B. Then you've got, this 3 is called a scalar, and what that means is you just multiply each element in the matrix by this constant. So we take every number and multiply them by 3. So we get that. And because we need to subtract 2b from 3a, let's go ahead and do 2b, and then we can just subtract them. So 2b, you're going to multiply b, this matrix, by 2. So you get this times 2, this times 2, this times 2, etc. So you get 4, negative 2, negative 2, 16. And then if you want to take 3a minus 2b, just take this minus that. So we have 3 minus 4 is negative 1. Negative 3 minus a negative 2 is 3 plus 2, which is negative 3 plus 2, which is negative 1. 6 minus negative 2, 6 minus negative 2 is the same as 6 plus 2, which is 8. And negative 3 minus 16, which is negative 19. Okay, so that's problem number 1. Problem number 2, we have this. This has 2 rows and 5 columns. So this has 2 rows and 5 columns. And that's one thing about subtraction and addition, is you have to have the same dimensions for the matrix to do that. We couldn't add this plus that. It doesn't match up. Okay, so do the same thing. What do? We're going to do BA plus B. So it has the same size matrix. And we just add the corresponding row column combination. So we take this plus that. That gives us 3. 2 plus 1 is 3. 2 plus 1 is 3. Negative 1 plus negative 1 is negative 2. 0 plus 0 is 0. 1 plus 1 is 2. Come down to the second row. 1 plus 4 is 5. 1 plus negative 3 is negative 2. Negative 2 plus 9 is 7. 2 plus negative 6 is negative 4. and negative 3 plus negative 7 is negative 10. Okay, so that's adding the matrices together. Then you have subtracting. So again, we're going to subtract instead of add the elements. 2 minus 1. Here we had 2 plus 1 is 3. 2 minus 1 is 1. 2 minus 1 is 1. Negative 1 minus a negative 1. That's negative 1. Minus a minus is plus, so you get 0. 0 plus 0, or 0 minus 0 is 0. 1 minus 1 is 0. 1 minus 4 is negative 3. 1 minus a negative 3, that's 1 plus 3, which is 4. Negative 2 minus 9 is negative 11. 2 minus a negative 6, that's 2 plus 6, which is 8. Negative 3 minus a negative 7, that's negative 3 plus 7, which is 4. Okay, so that is subtracting. The third one is just multiplying by a constant. So you take the original matrix A, just multiply each one of these by 3. So we'll have 6, 6, negative 3, 0, 3. 6, 6, negative 3, 0, 3. We'll have 3, 3, negative 6, positive 6, negative 9. 3, 3, I'm just looking over here and then going right. 3, 3, negative 6, 6, negative 9. Again, because I'm doing this, I need to do 2b. So that means I multiply each element in b by 2. So I'm going to have 2, 2, negative 2, 0, 2. 2, 2, negative 2, 0, 2. And then I multiply all these by 2. I'll get 8, negative 6, 18, negative 12, negative 14. So that's each one of these multiplied by 2. And then the process of 3a minus 2b, I'll just take this and subtract that. 6 minus 2 is 4, 6 minus 2 is 4, negative 3 minus a negative 2, that's negative 3 plus 2, which is negative 1, 0 minus 0, 0. 3 minus 2 is 1. So that's the first row. 3 minus 8 is negative 5. 3 minus a negative 6 is 9. Negative 6 minus 18 is negative 24. 6 minus a negative 12 is 6 plus 12, which is going to be 18. And negative 9 minus a negative 14, negative 9 plus 14 is going to give me 5. Okay, so that's problem number 2. Now the next thing we're doing is multiplication. Now multiplication, you have to have, they don't have to be the same dimensions, but they have to be such that if you take the number of, you specify the dimensions of a matrix by the number of rows times the number of columns. So this is a 2 by 5 matrix. This is a 2 by 2 matrix. So if you're multiplying a 2 by 5 and you're multiplying that by a 2 by 2, that doesn't work, because these both have to be 2. They have to be the same, and they're not the same. So if possible, this turns out to not be possible. So 4, not possible. And if you try to do that in your calculator, if you've ever done matrices, it'll say error. Now I could do B times A. So that would be 1, 5, 4, 2 times 1, 0, 3, negative 2, 6, 13, 5, negative 15. And the way that works is you take this times that and that times that, and you add them together. So you take row 1 times column 1 and add them. So 1 times 1 plus 6 times 5, so it's 1 plus 30, so you get 31. Then the next one is you do this times that. So you take row 1 times column 2, row 1 column 2. So you'd have 1 times 0 plus 5 times 13. So that's 0 plus 5 times 13 is 65. So you end up with 65. The next one, you take row 1 multiplied by column 3. So you'd have 1 times 3 is 3, 5 times 5 is 25, so that's 3 plus 25 is 28, etc. Okay, they didn't ask us to do that, but just explaining how it works. Okay, number 5, this is a 3 by 3 matrix, and this is a 3 by 3 matrix. So we can take a 3 by 3 and multiply by a 3 by 3 because these are both 3. Now it turns out that the resulting matrix is the outside. So the inside tells us whether it's possible to do it. The outside tells us what the resulting size is. So up here, when we're doing this is a 2 by 2 multiplied by a 2 by 5. So this said we could do it, and this said the resulting matrix is a 2 by 5, which it is. It's 2 rows by 5 columns. So that's how I knew that that was the right size. So what this does is it tells us two things. It tells us that the product, these multiplied together, is going to be a 3 by 3 matrix, and it's possible. So we can make a 3 by 3 matrix here just to have spaces. So the way it works is it actually is better if you put these next to each other. So what I'm going to do is I'm going to take my matrices over here, and I'm going to highlight this. I'm going to put that together as a group. Let's put that over here. I'm going to squeeze it down a little bit so I can have space. Here's my result. Okay, do the same thing here. I'm going to, okay, format, group, bring that over here, make it a little smaller. I need to get rid of this B thing here. Okay. Okay. So the rule is you take row 1 times column 1 to get your first entry. So you take 1 times 3. So I'm going to explain it for the first couple, and I'm just going to do it. So my entry here is going to be 1 times 3, 1 times 3 plus 0 times negative 4 plus 0 times negative 1, which these are all 0, so you get 3 as the answer. Okay, let's do the next one, which is this one. So this is the second column. So what we're trying to do here is we're going to do, actually we're going to do this one. So this is row 1, column 2. So you take row 1, column 2. So there, it's going to be the same kind of deal. You're going to have 1 times, instead of 1 times 3, you're going to have 1 times 1 plus 0 times 7 plus 0 times 2. So you can see those go to 0, so this ends up being 1. And let's do the one down here. So then we're going to take, this is the second row, first column. Second row, first column. So you take this times that, 0 times 3 plus 0 times 3, 4 times negative 4, and then 0 times negative 1. So you take this first element in the second row times the first element in the first column, second element in the second row times the second element in the first column, third element in the second row times the third element in the third column. And you see these both go to 0, and so you get 4 times negative 4, which is negative 16. Okay, so I'm just going to show you the remainder as I do it. So first row, third column, first row, third column, you get 2 times 1 plus 0 times 0 plus 0 times 1. So the only thing we get anything from is the 1 times 2, so that's 2. Second row, second column, that'll give you this one. So you take 0 times 1 plus 4 times 7, which is 28, plus 0 times 2, which is 0. So the only one that actually is non-zero is this one, which is 4 times 7, which is 28. Here we have, this is a third row, the second row, third column. Second row, third column. So you have 0 times 2, 4 times 0, 0 times 1, which is they're all zeros, so you get 0. This is the third row, first column. Third row, first column. 3 times 1 is 3. 3 times negative 4 is negative 12. So you have 3 minus 12, which is minus 9. And then we do these two, minus 9 minus 2 is minus 11. Then we do third row, second column. Third row, second column. 1 times 1 is 1, plus 3 times 7 is 1, plus 21 is 22, and then 2 times 2 is 4, so you get 1 plus 21 is 22, plus 4 is 26. And then the last one, you're doing the third row, third column. Third row, third column. So you take 1 times 2 is 2, 0 times 3 is 0, 2 times 1 is 2, so you get 2 plus 0 plus 2, so that's 4. And that's the answer. That is whatever we're doing here. This is what the heck problem was that? It was this, I copied them over. It was these two multiplied together. So again, reviewing the first matrix, you have to look at the dimensions in the matrix. The middle dimensions, when you line these up, have to have the same dimensions, otherwise you can't do it. The outside dimensions, the ones on the outside, are the resulting size of the matrix. Then to get the entry in the resulting product, you take the first, in this case it's the first row, first column of the final matrix. You take the first row of the first matrix, multiply by the first column of the second matrix, and there's 3 entries, and you multiply each one. 3 times 1 plus 0 times negative 4 plus 0 times negative 1, you get 3. So that's kind of how it works. Okay, so here we have this is a 2 by 1, 2 rows, 1 column. This is a 1 by 4, 1 row, 4 columns, rows by columns. So we're taking a 2 by 1, multiplying by a 1 by 4. So these are the same, so check, we can multiply them. The resulting matrix is a 2 by 4 matrix, which is kind of big, but that's the problem we were given. So let's just put them next to each other. 10, 12, multiplied by 6, negative 2, 1, 5. Okay, so in this case, the answer is a 2 by 4, so it's going to look something like this, 2 rows by 4 columns. So we take the first row times the first column, first row, second column, first row, third column, first row, fourth column. So we get 10 times 6 is 60, 10 times negative 2 is negative 20, 10 times 1 is 10, 10 times 5 is 50. Okay, and then you do the same thing down here. 12 times 6 is 72, 12 times negative 2 is negative 24, 12 times 1 is 12, 12 times 5 is 60. So that's the resulting, that's A times B. Okay, the next one says write each system of linear equations as a matrix equation and use Gauss-Jordan elimination on the augmented matrix to solve for the matrix X. Okay, so this is kind of like the previous section, except we're just writing this in matrix form. So the matrix, you have what's called the coefficient matrix, which is the numbers in front of the variables. Then you have a matrix, which is the variable matrix. So it's x1, x2, and that equals the right-hand side matrix. And so what it's saying is that if we wanted to write this, if we wanted to get back to the original part and we were multiplying these two matrices together, this is a 2 by 2, this is a 2 by 1. So it says, yes, I can multiply these together because these are both 2's, and the resulting matrix should be a 2 by 1, which it is. So this is your 2 by 1. And then the matrix multiplication says that I'm going to take, if I do this as a matrix, I'd have 2 times first row, first column, plus first row, second column. So I take 2 times x1 plus 3 times x2 equals 5, and then I do, well, actually what I'd say is this, like that, and then I have 1 times x1 plus 4 times x2 equals 10, and because these are both the same size matrices, you can then take it out of matrix form and get back to your original non-matrix form. Okay, so that's how it works. So that's part A, is to do that. Now it says use Gauss-Jordan elimination on the augmented matrix to solve for the so the augmented matrix is this matrix A. This is my matrix A. This is my variable matrix, and this is my right-hand side matrix. So what they're saying is that my augmented matrix is my coefficient matrix, which is going to be 2, 3, 1, 4, augmented with the B matrix, which is 5, 10. Okay. Now that we have the augmented matrix, we're going to solve it. So first thing you do is you switch the 2 rows, because I have a 1 here and I want it up in the upper corner there. So that's it. First matrix operation, switch the rows. The next thing I would do is I would take row 2 from my previous case here, row 2, row 1, and I would subtract 2 times R1. So let's take row 1, so this is going to be 2R1. So multiply all these by 2, so I get 2, 8, 20. And then I'm going to take this row and I'm going to subtract that row. Now the first row stays the same. I don't do anything to that because it's already what I want. So I'm going to take this minus that, replace it there, so I get 0. 2 minus 2 is 0. 3 minus 8 is negative 5. 5 minus 10 is 5. Okay. I want to get a 1 here, and you can see there's this common factor, so that's nice. So I'm going to take row 2 and divide by negative 5. Leave row 1 the same. So I get 1, 4, 10, 0, 1, negative 1. So if I divide this by negative 5, I get positive 1. Divide that by negative 5, I get negative 1. Now, I could use back substitution, but they're asking use Gauss-Jordan elimination. So now what I'm going to do is I'm going to leave row 2 the same, and I'm going to take row 1, and I want to get this to be 0. So I'm going to subtract 4 times row 2, because if I multiply this by 4 and subtract it from this, I'll get 0, which is what I'm trying to do. So let me go ahead and write 4R2. So this is R2. This is my new row 2. This is my new R1, which is the same as my old R1. So I'm going to take 4 times this. So I'll get 4 times 0 is 0. 4 times 1 is 4. And 4 times negative 1 is negative 4. And then I'm going to take row 1. I'm going to subtract 4 times row 2. So I get 1 minus 0 is 1. 4 minus 4 is 0. 10 minus the negative 4 is 14. So what that says is x equals 14 and y equals negative 1. Let's just double check that. So you get 2 times 14. Uh-oh, did something wrong here. So what did that do? Okay. Let's go back and look at this, so you can see it's good to check. So let's just double check everything here. So these are okay. Flip around, so that's okay. First thing we do is we take 2 times row 1. We subtract that from R2. So you take this minus that is 0. This minus that is that. This minus that. Ah, there we go. Is that right? No. There's the mistake. Okay. This is not 5. So 3 minus 8 is negative 5. 5 minus 20 is negative 15. Right there. So then if we divide that by negative 15 by negative 5, we get positive 3. Okay. And then now if we take 4 times this, we'll get 4, and we'll get 12. And then if we take row 1 and subtract 4 times row 2, we'll get negative 2 here. Yeah, I was kind of wondering. I was surprised that was. I was surprised that was 14. That didn't seem quite right. So I should have thought about that. Okay, so what you get is y equals 3, x equals negative 2. Okay, now let's check it out. Plug that back in. So you got 2 times x, which is negative 2, plus 3 times y, which is 3. So that's 9 minus 4, which is 5. Check. And down here you'd have negative 2 plus 4 times x2, which is, well, I did y. That should be x1 and x2. So let me make sure I do that right. So I get 4 times x2, which is that. So you get 12 minus 2, which is 10. Check. Okay, so that is the solution. Oh, that's it. Okay.